going to have a look at word problem number 20. And I'm going to do this with the calculator. So I went ahead and entered it in this calculator. So negative 4.9, it uses x. It's the same as t squared plus 97x plus 430. And we can look at a graph. One thing that you know from this one, so NASA is launching a rocket at t equals 0 seconds in meters above sea level, right? So when we get this graph, one thing that you know before you start is your y-intercept is going to be the height that it launches from, and that is when you put 0 into this t. So it's launching from 430 feet. So we are going to have to change the window. But first I just left a standard window, and we'll go ahead and say graph. And this is what I get for a standard window. So it's not giving me any information. It's not giving me the parabolic pathway. And so I need to change this. And so I am going to do zoom fit to get an idea of how to change it. And that's 9. Enter. Right, and that helped some, but I want to know when this splashes down, so it didn't give me as much information as I wanted. So I'm going to look and see what their scale is. I really don't need any of this part over here to the left, so I can cut some of that off, and I certainly don't need to go down this much. Let's look and see at their window. All right, so they didn't change the x and the y at all. I mean the x at all. So I'm going to change the x some. Let's change the x max. Let's change it out to, we'll say we'll go to 100. And let's change our tick mark to 10. All right, and I want to change the other one, the y min. All right, so that is the part below the x-axis. I don't need that much of that. So I'm going to change that to a negative 500. But I'm going to change my max. Let's change it up to 1,000. And let's change our tick marks here to 10. All right, so just to try to get, we need to get the whole parabola so we can get the vertex and the x-intercept. All right, so this is a fairly good graph of this one. The x-intercept is the easiest one to pick off, or to me it looks the easiest, and that is where the rocket's going to splash down. All right. And so what we want is the x-intercept. In your calculator, it will be the 0. So we're going to do second calc 0. That is the same as the x-intercept. Right. And they're saying a left bound of 45. All right. Right here is the point we want, the x-intercept. We let these tick marks be 10. 45 is way out here, so that is too much. Let's let it be 20, so 10, 20. That way we're getting in between. So left bound, I'm just going to enter 20 and click enter, and it will fill that in. All right, so it shows us where it is on there. All right, and now we have to enter a right bound. Let's enter 30, because here would be 30, and that is definitely going to have the 0 in between. So right bound, we'll put 30, enter, and now let's click guess. right? And that gives us our x-intercept. And let me move it over here so it'll stay lit. So x-intercept from the calculator this is a 0, is 23.526, and that's far enough because they said to round to 3 places. So 23.526 is what we'll put in for that one. All right, and that will be our first answer. And we'll see if that looks good. That one looks good. These may not be exact getting from the calculator, but it should accept them because it's programmed to accept within a certain range. All right, after how many seconds after the launch does the rocket reach its peak height? All right. It wants to know the x value of the vertex. The peak height is the y value of the vertex. How far out it is the x value, or where it's located. So we want the x value of the vertex. And this vertex is a maximum because it's turned upside down. All right, and so to get there, we will go under second calc. So second calc, we'll choose maximum 4. All right, now we have to get to the left of that. So let's say 10. I think 10 is clearly to the left. Might not be. Let's say 5, just to be safe. See where 5 is. No, 5 is probably a better guess. All right, so we are to the left of the top, and let's see. This would be 20. So if we say 15, so we're just trying to get it boxed in, kind of. All right, that's a good right bound. And now we'll say guess. All right, and that is telling us at the x value is 9.8979, and that's as far out as I need to go, because to 3 places, this 9 is going to push us up. So 9.898, and then the maximum height is the y value of the vertex. So we've already done all the work. And it is 910 meters, 0.0510, and that we can drop off. All right, and we can check these. All right, so we checked this one, I think. All right, it reaches its peak height at, this is what I have, 9.898. And the peak height would be 910.051. And I think the calculator is the best way to do this. You could do it by hand with the negative b over 2a. And then you would also have to set 0 equal to it and use the quadratic function with the decimals and the big numbers if you are going to do it by hand.